goes? Yeah, okay. Works. I think we still wait for 1 or 2 minutes. Maybe somebody is still checking out. Somebody's still sleeping, waking up on the party now, yeah. Okay, I think I will start. My name is Stefan. I am from Microsoft. I am a technical solution specialist, so my responsibility is the analytics platform system, and I am doing quite a lot of, let's say, pre-sales, project, training, so all what has to do with market introduction. I am in a group called Incubation, and Microsoft Incubation is for products which need special handling. So, and I'm responsible for Central Eastern Europe. I'm based in Munich. So Central Eastern Europe in Microsoft's terms is something between Malta, Baltics up to Russia, Mongolia, so a large area. Okay. Let me start with it. This is the only, let's say, marketing slide here. I promise not to make too much marketing. What is this showing is basically the Gartner quadrant of data warehousing, and you can see that Microsoft goes into higher and higher up into the leader quadrant. And this has, of course, something to do with SQL Server 2014, always on, availability groups and all that kind of stuff. But it's also part of the parallel data warehouse, which has been rebranded as application platform system. I will show you what it means, application platform system, parallel data warehouse. It's basically the product I want to present you now. Okay, I will give you an overview. I will show you some features, so basically that it is massively parallel, how data is distributed in such a parallel system. I will say something about columnar storage, about Hadoop integration, and about analytics handling. By the way, you can ask questions, so we are not so many people, so when we come to the different points, we can discuss about it also. It's not just a talk. So, what is it? If you order such a thing, it's not a download, it's not some CD, but it's coming basically with a big truck. It's installed by a hardware partner. The hardware partners here are either Hewlett-Packard or Dell. It's tested, it's set up, it has already the databases and all the file groups and all the internal networking installed. It is a massively parallel system. Oops, what happens now? It has in-memory column store. I will show you. You can have a data warehouse on it, but you can also have a Hadoop system on it. You have query model, and I will say something about this, which joins Hadoop and SQL in the same moment. Okay, I think here I want to explain you what is this box. Basically, it's a control node who knows that this box is a massively parallel system, and there is a lot of compute nodes, which are database servers, who run SQL 2014 and have on their own data. So what does it mean? You have, for example, a query coming in. This box knows we are parallel, so I put this query in the form of a parallel query and distribute the query to these different databases. Each of them has a part. These two are, this one has half of the disks, this one has half of the disks. So each of them goes to their own data, query their data, give results back, and the client gets the final results. Let's make a simple example. You want to have the sum of the revenue of yesterday. So basically this one tells each of them, look into your AdventureWorks database, sum of your revenues from yesterday, give me your partial sum of your data, and this guy makes a sum of the partial sums, full sum, and gives back the results. Of course, this is a very simple question, very simple example. Let's make a little bit more complex example. How many distinct customers have been there? Count distinct. To do a count distinct, it is not good to sum the distinct counts of these, so you have to do something else. So for example, you say count distinct, so this guy gives back a sorted list to this guy, and he is running linearly through the sorted list and gives back the result. Because if you have a pre-sorted list, you can do it very fast. If we would do it like this, it would not be good, because we would have here, one point who has to do everything. So basically, this guy tells these guys, give your sorted list to one randomly selected, and the randomly selected is working on this. And for the next query, another randomly selected is giving back the results. So basically, the idea here is to make a query plan. This guy has to be quite intelligent, and these guys, to make a sorted list, it's basically SQL. It's SQL 2014. Sometimes you need a join. For example, data of this guy has to be joined to data of this guy. For this, we have a very fast connection between these, among these nodes. It's a fast InfiniBand with 56 gigabit per second. So basically, it's the fastest which is available on the market presently. All these boxes are running Windows Server 2012 R2, all running in a virtualized environment. All these boxes have the same hardware. They are there are two processors, 8 cores each, and they are running on virtual machines. So if this guy fails, the virtualization spare, the failover node, can run this virtual machines of this one. So it may happen that this guy has a problem. So this one can take over. The same here. If this one is failing, this guy can take over. So basically, there is a redundancy in the system that the virtual machines can fail over to this one, and a redundancy in the disks. They are RAID 1, they are hot spare disks, and so on. So basically, this box has no single point of failure, runs massively parallel. If you load data in it, for example, you load data randomly to all these boxes. They look where the data belongs and send the data to the rest. So everything is running in parallel. The query plans look, these boxes here run a so-called data movement service. So if you look in complicated query plans, you see a lot of something like pre-aggregate this here and then run a data movement service to them, then join, then run a data movement service to this box and give a result back and create statistics here. So basically complicated queries have a quite complex query plan, but the query plan is as much parallel as possible. I will go a little bit more into this question in 2 slides. If you have this massive parallel system, it means basically that you can have a small system, you add simply more of these compute nodes, you add more of these compute nodes, and you can scale up to up to 7 of these racks, so you can go up very, very high. The smallest system is a so-called quarter rack. Let me make it very simple. Very often customers ask me, if I buy a quarter rack, I have to buy the full system here, it's some price and so on. Why shouldn't I take a SQL server with a lot of SSDs for the terabyte of RAM and all that stuff? It should be as fast as your quarter rack. It's true, you can do this. But if you grow your data, you here, with a massively parallel system, you just add. So, and if you have an SMP system, so basically the classical SQL server, you just come to an end. For example, I had a project quite 2 weeks ago where we had a customer who had something like 90 terabytes on 2 SQL servers, and they used some quite interesting setup. They had linked servers, and they were running the queries and tried to run the queries as local as possible and then link the servers and do something like this. And they came to the end. So basically they said, okay, 90 terabytes, nice, but now I have a problem. I cannot do it anymore. And we were going in with the smallest system at all, and in a lot of queries we were 5 times as fast as they were with their linked servers. And they now will order this kind of system. SQL in parallel data warehouse, these boxes running, basically you pay SQL licenses for these boxes. These boxes are running 2 times 8 core. So basically for the smallest one, you have 16 SQL licenses. Yeah. Additionally, you run SQL, you run System Center for the virtual machines, because everything is to be monitored from System Center. Additionally, you run Windows Server for the virtual machines. But the big cost part is basically the SQL licenses. The SQL licenses, as I said, they are per core based. So you have 16 2-core packs for the smallest system here. You need it. They are running in a virtual environment, but basically the SQL is basically 1 virtual machine per box. If you have Hadoop, you have 2 virtual machines, because somehow you have to balance the number of processors or workhorses to the number of disks, because these are 70 hard disks. The next thing is, I want to say something about data distribution. Very often in data warehousing, you are joining fact tables to dimension tables. In order to do this, you need, of course, the same data in the same processor, in the memory. So what do? We have fact tables can be quite large. They can be billions of rows. Dimension tables are normally something like 1 million of row. Of course, if you are China Telecom, you can have 1 billion of customers, but customer database is something in 1 million, something like this. So what do? We distribute, we replicate the products, the dimension tables, and put a copy of them to each of these compute nodes. We are distributing this table. So basically part of this table is here, part of this table is here, part of this table is here, part of this table is here. So if you join, for example, on a date, or if you join on a store ID, you can do this locally. So you do not have to shuffle the data around. Of course, and now we're coming back to the same question before, the optimizer, if you have to send data around, the optimizer needs statistics to understand what to send around. So to have less data to send around and do the local join then. So basically what I already said, the fact tables are distributed. So what does it mean? If you have, I will come back to the last again. These boxes have 8 cores each. So 2 processors with 8 cores. So what do? We do not distribute it only 1 to here, 1 to there, 1 to there, 1 part to here, but we distributed it here to 8 so-called distributions, to 8 distributions here, to 8 distributions here, to 8 distributions here, so that each core has their own data. So basically they can also run in parallel. So this system is really optimized for parallel handling. So basically in this kind, the distribution factor is 4 times 8, so 32. So basically you have 32 processes running in parallel. So you do not have only a distribution of a parallelization of 4, but in reality you have 32, which are running, everybody is running in parallel. So what does it mean? If you create a table and you tell them you want to distribute it, this distribution, I say it very simple, then it's distribution on 8 per compute node. So if you have a full rack with 8 compute nodes, you have 64 so-called distribution file groups where each core is assigned to one of these. How do you distribute? And this is something you have to say to the box. You distribute it, for example, on customer key. What does it mean? There is a hash on the customer key. The hash on the customer key is doing, the hash on the customer key is hashing, and the hash is telling it go to this place or go to this place. Basically, that means that every entry which has the same customer key is on the same place. And that has something to do. That has some sense. You have to think a little bit. Because if you mostly do, for example, shopping basket analysis, you would like to have everything, every order which is in the same shopping basket, you would like to have them on the same place, because in a shopping basket analysis, you have to make a very complex join. You have to have a join of the fact table with the fact table, what is brought together. And in such a case, for example, you do not want to move the data around, but you want to have every data which is in the same shopping basket together in the same place. So you would, for example, distribution as a hash of transaction ID, customer ID, if you know the customer, or something like this, or store ID. What you also would like to do is to have them evenly distributed. So for example, a hash on the date is not a good idea, because if you make a hash on a date, everything from yesterday is here. Everything from 2 days ago is here. It's evenly distributed, but typically customers are looking for the orders of yesterday. They want to know what happened yesterday. Did we have any problem? So everybody is asking this guy, give me your results back. Everybody else is idle, doesn't do anything. So you would, in this case, only one of these boxes would work, one of these distribution, one of these cores would be hot, and the rest is idle. So you wouldn't do this. Let me come to the next one, column store. It's maybe known from SQL Server. What do? You load data until you have roughly 1 million rows. When you have 1 million rows, you put it into each column in their own group, compress it, put some overhead in it, for example, maximum, minimum, average, and all these kind of data of statistics, and fill it here. What are the advantages? The first advantage is, here is, for example, customer ID. Here is first name. Here is middle name. Here is second name. This is integer. This is varchar. This is varchar. So you can compress much better because you compress with a very specific way, depending, you only compress integers. You only compress varchar. So you have a better compression factor. We are measuring in systems which have a lot of nulls and all that kinds, we are measuring compression factors of around 10. If you have, I'm working next week, I'm going back to an antivirus company, they have a lot of binary files, you have a compression factor of maximum 2. So it depends a little bit on the data. But nevertheless, in a telco environment, you can easily come to 10. If you have a query, and typically in the call detail records, for example, or transaction records, you have 50, 60 of these columns. You may need only 6. So you query only the columns you need. You have to extract only the data you need. You have less data, better compressed, faster, less columns. So you have much better I/O. You can keep it better in RAM. So basically with the in-memory handling, with the caching, you are faster. And you can execute it here in batch mode, so you take the hardware acceleration in. So with column store, you are much, much faster for queries, especially for data warehouse queries. I have to look a little bit on the watch. So basically, I come now to Polybase. Very fast, very, very short. In APS, we have a data warehouse part, we have a so-called Polybase, and we have some Hadoop storage. Let me say it very simple. A database, a table, is somehow, somewhere, a lot of pages and so on, but you can think about a CSV file. You have somehow a file, a structured file. If this file is here on this disk, if this file is on this disk, if this file is on Windows Azure, it's basically the same. We are just telling the parallel data warehouse, there is a table. The table is a CSV file. Think about a CSV file, but there can be other type of files. And this table is located on this IP address, on this location, with this kind of coding and so on. So you say create external table. Then you can do a select. This box is not looking in their own disks, but it's looking onto Hadoop. So the idea here is to create a table on Hadoop outside to make queries, to import them, join them, the same story as with the parallel data warehouse. So we are just querying data here via T-SQL. Customers use this, for example, to archive data back. So basically they have, for example, in a telco, they can archive their old data outside to Hadoop. If a police investigation comes and wants to have the data from calls from last year, they just say, they just select. In the old system, you would have to unarchive them, take them out of a tape library, put them onto import them, do the whole analytics, then clear the imported data because you don't want to have it to hang it around in the data warehouse, something like 6 hours to days, whereas here it's a simple query. So, for example, this is one example. There are other examples. So what does it mean? If you take T-SQL, you can use Excel, you can use Power BI, you can use everything. You query, and the data is either in Hadoop or here, you do not have to adapt anything. So the system doesn't notice anything. You can use your tools for T-SQL as before without having to adapt it to Cloudera, to Hortonworks, to Azure HD Insight or something like this. You just query. And of course, you can work directly with the Hadoop data if you're a data scientist and want to program. Last 5 minutes. So I want to say something very, very short about analytics. In this box, I get the question of customers. You have Hadoop, you have Azure Machine Learning, you have analytics in Azure. How do you do this? If you have 90 terabytes or 100 terabytes of data in your box, and you have Azure Machine Learning, you cannot shift 90 terabytes of data into the system just for one analytical query. And the next question is, how can Azure Machine Learning handle 90 terabytes or so? So I want to tell you how it looks in reality. Think about a telecom. And this is a real thing, because we had something like this. But the same story may be also in data in a bank or wherever. You have in a telecom, in a smaller telecom, you have something like 5 million users. Every user creates 100 of events per day, something like this. Each event has 2 kilobytes, and you keep the data for 3 months, just roughly. If you do this, you come to 90 terabyte. You come to 45 billion rows. But you never go with machine learning on this data. What you create is a so-called analytical data set. What you're doing typically is, for each user, you create the number of calls during the day, during the weekend, roaming calls, the sum of the bill, the payment history, and so on and so on and so on. If you do this, you have 5 million users, so 5 million rows, with maybe 100 of these entries, some average, roaming calls, whatever. 1 kilobyte per row to 10 bytes per indicator. So you're going back to 5 gigabyte and 5 million rows. So basically, doing all this summing and averaging, you would, out of 90 terabytes to create 5 gigabytes. This would be a typical job in the analytic platform system. You're doing all this pre-processing, data cleansing, all that stuff, what you can do. Then you are on this data. Second part, if you have this data, you even do not need to export all this data in order to do complex analytical tasks. You would typically sample, for example, 100,000 customers, because you would like to create an analytical model. What is an analytical model? If you have the data, somehow, for example, here is a support vector machine, but it could be also clustering or so on, you have to understand how to find cluster, groups, and structure. To do this, you do not need 5 million, you need perhaps 100,000. Then you do your model creation, which is complex, because you have to find structure in the data. When you have your model, it's very easy. You have one data point, and now this is easy to say, okay, which cluster is it? Which side of the boundary is it located? This is an easy task. So basically, for building the model in Azure, in R, Revolution Analytics, whatever, this is complex. You only have to export a small part of this 5 gigabytes, perhaps in this case, 100 megabytes. To apply the model to the 5 million customers, you also only export 5 gigabytes. You never move around 90 terabytes of all this data. The 90 terabytes you only have before you create your model, before you're doing, to create your analytical data set. Only here you have to do all the work. Okay. So this is my last or maybe not the last slide. The last slide will be in Croatian, I think. This is basically what is the special thing. This is a second marketing slide here, of course. It's basically, it's part of a family. If you look for the whole story, analytics, reporting, importing, you have SSIS, you have SSAS, you have SSRS, you have Azure and so on. If you look, this is much cheaper than, for example, buying an Informatica, buying whatever competitor product, buying some complex analytical reporting stuff. So we are much here, since it's an appliance, the DBA doesn't have to look for all the, let's say, for all the file groups, interface, failover groups, and so on. Everything is done by us. And we had in the US customers who said, okay, we want to do it by ourselves. And they ended up with a very, very high cost. Linear scaling, column store and in-memory, integration with big data and with all big data, also not only our own big data. So for example, in IBM you have the big data integration, but you only have with IBM's version of Hadoop. In Oracle, the same story. And here we can run with Cloudera, we can run with Hortonworks, so with the external Hadoop distribution. We are open in this case. And we have also a Hadoop inside. Of course, I'm saying we are much cheaper, but if you look for Gartner, they are saying the same, very low cost, price performance. So I think we are quite different here. Okay, sorry. Okay, it's something, I think it's some points, but you know it better than me. Thank you. Okay. There is in the virtual academy there is an analytic platform. It's going much deeper because I had 30 minutes, so I had to run through it a little bit fast. Okay. Yes, of course. Just I switch it off.
Čujemo se. Dobro jutro, dobar dan, kako kome? Ste dobro? Ko je bio na partiju sinoć? Pa šta ste svi penzioneri, niko nije bio na partiji. Možemo početi. Ja sam Damir Dobrić iz Frankfurta, tvrtke DNet GmbH. Inače smo Microsoft partner i Microsoft sam Most Valued Professional i partner TSP za Azure platform. Samim tome što je tema danas machine learning, to je sastavni dio Azure produkt grupe, pa ćemo da vidimo što ćemo se raditi. Da li je neko od vas već suočio sa ovom temom? Azure machine learning, niko nije ništa radio.